Hey guys, so I'm going to do a little recap here of some of the key points from 7.1. So the big idea in 7.1 is the rational root theorem. So that's talking about how we can figure out what zeros of polynomial functions might be. So we're going to begin by looking at a particular polynomial function that could be factored down into 2x plus 3 times x minus 2 times x plus 5. Now, I know some of you are still having a little trouble with factoring, so we may loop back around and talk about that a little more when I get back. But remember that there is a polynomial function of the 1, 2, 3, third degree that can be expressed in standard form, meaning there's an x cubed term, an x squared term, an x term, and a constant term that can be factored down into these three binomials. So we're imagining that we're thinking of that polynomial function that can be factored down into 2x plus 3 times x minus 2 times x plus 5. And we're saying we want to find the roots of it or the zeros of it. These would be the places where y equals 0 on the graph. So if you imagine that it's y equals this, we just called y 0 right here to figure out which x's make that true. So we're going to be looking at where it crosses the x-axis, and it's which values of x make the left side into 0. Well, if you'll remember, when everything's being multiplied, we only need one of these binomials to equal 0 in order for the whole left side to be 0. Okay? So that means here, if in the 2x plus 3 binomial, if my x is negative 3 over 2, so I change the sign here and then take this number and then put this coefficient in the denominator, that's one of my zeros. Because if I put negative 3 halves here, times 2, that makes it negative 3, plus 3 is 0. When this whole binomial is 0, it doesn't matter what these two things are because I'm multiplying. It's going to make the whole left side into 0. Okay, so one of my zeros is x equals negative 3 halves. Okay, then let's look at this binomial, x minus 2. What value of x would make x minus 2 into 0? Well, it would be x equals 2. Okay, so we'd say here x equals 2. That's one of our zeros. Okay, then finally, if we look at this binomial, x plus 5, what value of x is going to make x plus 5 into 0? Well, that would be negative 5. So x equals negative 5. So these are our three zeros. Okay? We know that because it's already factored. But the big question is, what about when a polynomial is not factored? Now, we learned synthetic division that helps us to figure out which numbers are zeros. But we don't know how to generate possibilities, and that's what the rational root theorem is for. So let's look at this. I'm going to multiply out these three binomials to get the polynomial that these are the factors of. Okay? So first I'm going to multiply these two, so I'll have 2x plus 3 equals, or times, x squared plus 5 minus 2 is plus 3x, minus 10 equals 0. Okay? Now I'm going to multiply this binomial times this trinomial. So I'm going to have 2x times x squared is 2x cubed. Okay. Then I'll have 2x times 3x is plus 6x squared. And 3 times x squared is plus 3x squared. Then 2x times negative 10 is negative 20x. 3 times 3x is plus 9x. Okay. Then 3 times negative 10 is minus 30. Okay. So now I'm going to combine like terms here and here. I'm left with 2x cubed plus 9x squared minus 11x minus 30 equals 0. Okay. Now notice, remember from the binomial theorem that we can think about the terms in this polynomial as being generated by their binomial factors by saying, I'm going to pull one thing from each binomial that's going to help me generate each of these terms. So for instance, in order to generate the 9x squared term, I had to pull 2 x's from among these 3 binomials and 1 constant. So I can do that in 3 ways. I can go 3 times x times x. I can say 2x times x times 5. Or I can say 2x times negative 2 times x. Those are the 3 ways I can get 2 x's and 1 constant. So it's those 3 products that combine together to make 9x squared. So the question becomes, how can I make my x cubed term? And how can I make my constant term? And we're concerned about that because that's going to tell us something about these binomials. Okay? So, for instance, if you look at how many ways can I make the x cubed term, you should remember from the binomial theorem that the only way I can get the x cubed term is by taking the first part of each of these binomials. It has to be the x part of the binomial every time. So that means that whenever I see a binomial, if I look at the leading coefficient, okay, that number, that coefficient will be the product of the coefficients of all the leading coefficients of these binomials. So any polynomial can be factored into a bunch of binomials with x to the first degree, or a bunch of binomials with x to the first degree and a quadratic, which is more 7.2 stuff. Okay, but it's helpful to recognize that this leading coefficient has to be the product of these leading coefficients in the factorization of the polynomial. So I'm looking for zeros or factors. So I'm looking for these zeros, which I find from the factorization of the polynomial. It's helpful for me to recognize that the leading coefficient of the expanded polynomial, the leading coefficient will be the product of these coefficients, no matter how many there are. Okay, in this case, there's 3. Then, similarly, how do I get the constant term? Well, in order to get the constant term, when I pull 1 from each of these binomials, it has to be the constant term of those binomials. So, the constant term in the expanded polynomial will always be the product of the constants in the binomials. So here, that 30 comes from 3 times 2 times 5. 5 times 2 is 10, times 3 is 30. So now, if we're looking for possible zeros of this, we take, if we consider this right here to be m, and this to be n, possible zeros, okay, are factors of m over factors of n. Okay, so we go, well, what are factors of 30? Those are 1, 2, and these can be plus or minus 3. 4 doesn't work, but plus or minus 5, plus or minus 6. Sorry. Plus or minus 6, plus or minus 10, plus or minus 15, and plus or minus 30. And then the n's, so these are the m's. The n's are factors of 2. So that's just plus or minus 1, plus or minus 2. Okay? So there's obviously a bunch of possible zeros, but we can try the easy ones first. Okay, but just notice here that negative 3 halves, sure enough, you take the 3 from here and the 2 from here, you generate that 0. X equals 2, you take the 2 from here and the 1 from here. X equals negative 5, you take the negative 5 from here and the 1 from here. Okay, so it's 5 over 1, 2 over 1, and 3 over 2. Those are my 3 zeros. And so what you do is you use this knowledge right here to generate your possibilities. Then you start with easy ones like 1, 2, and 3, and you drop those into synthetic division. Okay, and that will then give you an indication. Once you find one of those that's a factor, then you've ended up with a quadratic, and quadratics we know how to factor. Okay, we know how to break down into two binomials because we've been doing that since Algebra 1. So once I can find that first one, it tells me how to find the next two. Okay, so that's the basics of the rational root theorem. Okay.